Dimensional analysis is a very useful tool in physics. We'll see why in a minute. Let's understand what we mean by a dimension in this context. The dimension we're talking about here has nothing to do with the spatial dimensions that we're so used to when we talk about 2D art or 3D movies. Forget about that kind of dimension and let's start from scratch. Every physical quantity has a dimension. The dimension of a quantity is independent of its units. For example, 3 feet and 10 meters both have dimension of length. The shorthand for the dimension of a quantity Q is square bracket Q. The dimension of the quantity shows us all the base quantities that make up that physical quantity. For example, speed has the dimension length over time. We usually use L, T, and M to mean length, time, and mass respectively. You can guess the dimension of a quantity from its units. For example, the speed of a car on a highway might be 70 miles per hour. Miles measure length and hours measure time, so the dimension of speed is just length over time as we just saw. Lastly, quantities with different dimensions do not add. You simply can't add 5 seconds to 2 feet. The idea of dimensional analysis is simple. You just have to make sure the dimension on the left-hand side of an equation equals to the dimension on the right-hand side of the equation. You can use dimensional analysis to do sanity checks, making sure that your final answers make sense, or guess the form of a physical law. However, you can only guess the law up to a proportionality constant. For example, Hooke's law says that the elastic force F is equal to 1/2 kx squared. Using dimensional analysis, you may be able to guess the kx squared parts, but you won't be able to come up with the factor of 1/2 because 1/2 is just a number. A number has no dimension or dimensionless. Alright, let's guess a physical law using dimensional analysis. Here's the problem. The dimension of any force F is m times L times t to the power of minus 2. Suppose the expression for centripetal force involves radius of a circle, r, speed of an object, v, and mass of the object, m. What is the form of the expression for centripetal force? FYI, a centripetal force is the force that keeps an object moving in circle. Sun's gravity on the Earth is a centripetal force that keeps Earth moving in its orbit. Anyway, back to the problem. We should start with the most general form possible for the centripetal force. Also, since we can only know the expression up to a proportionality constant, we should start by writing down Fc, which stands for centripetal force, is proportional to r to the power of a times v to the power of b times m to the power of c. R, m, and v were given by the problem. A, B, and C are just numbers. They can be positive or negative or fractions. We have to find out what A, B, and C are using dimensional analysis. Recall that the key to doing dimensional analysis is that the dimension on the left-hand side is equal to the dimension on the right-hand side of an equation. Let's start with the dimension on the left-hand side. Since centripetal force is a force, its dimension must be the dimension of force, which is m times L times t to the power of minus 2. This was given by the problem. Now let's look at the right-hand side. The dimension of r, the radius, is L, since it is a length. The dimension of v, the speed of an object, is L over t, which we talked about earlier. And the dimension of mass is m. Putting all these together, the dimension on the right-hand side is L to the power of a times L over t to the power of b times m to the power of c. Doing a bit of algebra, we get L to the power of a plus b times t to the power of minus b times m to the power of c. Equating the left-hand side to the right-hand side, we get this. If we look at only L in this equation, we see that L must be equal to L to the power of a plus b. So 1 is equal to a plus b. That's our first equation. If we look at t only, we see that t to the power of minus 2 is equal to t to the power of minus b, which means b is equal to 2, our second equation. Lastly, if we look at m only, we see that m is equal to m to the power of c, so c must be 1. Going back to equation 1, since b is 2, a must be minus 1. That's it. We've found the values for a, b, and c. Putting them back to our general expression, we get fc is proportional to r to the power of minus 1 times v to the power of 2 times m, or mv squared over r. Now we can put a nice box around our answer.